Welcome to Digital Disruption 2014 and our Catalyst live streaming event. I'd like to welcome you here to discuss the MultiCloud SDN-NFV service orchestration. We're going to be discussing how that project was conceived, how it was actually feeding back into the TM Forum technical programs. And to do this, I'd like to introduce you to Eric Troop.
Thanks, Ken. So we're going to be talking about, as Ken described, the MultiCloud SDN, the Network Function Virtualization Service Orchestration Catalyst. And I'm Eric Troop. I'm the CTO of Comms and Media Industry at Microsoft. Just a brief overview on the Catalyst and what we were attempting to address in terms of technical issues. So this is a multi-cloud software-defined networking, network function virtualization, service orchestration catalyst. And we are in the midst of deploying these types of technology, and there are a lot of issues around how do you manage service delivery over a multi-cloud, a public cloud, MPLS cloud, a service provider cloud, and all the way out to the access network. Ultimately, we're streaming content from a cloud over a network to a mobile device, and we want that user experience to be very, very good. So in this catalyst, we're focusing on how do we monitor and control quality of service across those clouds, and how do we trigger appropriate virtual network functions to improve service quality as needed. And not only how do we instantiate those capabilities, but how do we uninstall them as needed, up and down as needed, so that we're constantly tuning the user experience. We had quite a few partners engaged on this, as you can see on this list. Many of these partners have technologies that we're trying to stitch together to create a capability to manage service quality over a multi-cloud environment. We're going to show you what that looks like. So thanks to all of the sponsors and participants. So what is the problem we're trying to solve? And we're really dealing with not just small delivery of small amounts of services, but we're really dealing with very large volumes that put extreme loads on the network. Not just the data center fabric, the network under the data center, but the network that extends between the data centers and the network that extends all the way out to the edge. So not only do we have these high workloads that you can see listed in the boxes here, but we also have tremendous load on the network itself. So in our case, we are deploying these kinds of technologies. We're really using these kinds of technologies, and we need to advance our capabilities in collaboration with all of our partners to enable a better user experience for the delivery of these digital services. So conceptual architecture that we're evolving towards is represented by this chart. Basically, all of the network capabilities and all of the IT capabilities are moving to a common cloud infrastructure. And so we need a common approach to managing the entire stack to quickly deploy new services and adjust the quality of service, and to react to events such as an unexpected denial of service attack that's impacting results, and how do we mitigate that efficiently. So let's take a look at the logical proof of concept setup. Basically, we are depicting a service that's streaming across a network that has three clouds, if you will. A public cloud represented by Microsoft Azure, a MPLS cloud that was created using some components from Metronome and an MPLS switch from Cisco, and a private cloud based on the Microsoft Cloud Platform. And you can see that we're using the VXLAN tunnel to go across that. And then above that, we're using SEV1 to do some monitoring, and we have a virtual network controller. We have an orchestration layer. We're using System Center, and we're using the Microsoft Azure Pack to give you that self-service capability. So basically, we're putting a load across this network. We're stressing that load with some event, and we're demonstrating what needs to be done in order to adjust resources across not just one cloud and one network, but multiple networks to enhance that user experience. If you wanted to see what the actual POC looked like, this is the actual equipment that was actually built and set up. You can see we have 3 Dell racks of equipment that constitute the private cloud. We have the Metronome and Cisco equipment that constitutes the MPLS. And then we have a link back into Azure, and we're able to look at both ends from the remote desktop that allows us to see both ends. And we're able to monitor with real-time analytics all sorts of events that are going along throughout this. And of course, the real-time analytics piece is pretty important to being able to dynamically see things and react to them appropriately. So this is a continuation of some work that's been overseen by the TM-Form Zoom project. There was a previous catalyst, but in this case we're using some newer equipment, and it turns out that we're actually trying to productize some of this equipment, and there are still some engineering issues to be dealt with in terms of integrating with other vendors and achieving service orchestration across multiple virtual network controller domains. So here we're using software-defined networking and network function virtualization deployment management capability from Microsoft. We're managing and monitoring the state of quality of service, or the quality of service SLAs, across both an enterprise, a communication service provider, and public cloud. And we're improving service reliability and quality by invoking new services or virtual network functions into a service chain as needed to improve the service quality or to respond to a changing condition. So we have 2 use cases, and the first use case, we have a load on the network, and we're just here using a streaming video. This could be Link, or it could be Skype for Business, or it could be streaming the Olympics or the World Cup, but somebody is streaming a video and they want a good user experience. And through our real-time analytics, we detect insufficient bandwidth that's violating an SLA that has been provisioned. And in response, policies are invoked that, because the policies have been pre-configured, resources related to quality of service are adjusted across the network at multiple locations to meet the new service level requirements. So an example of what we mean here is somebody could be doing something on the network, and then all of a sudden they start playing the video. The video puts an increased load on the network, rather than just providing extra resources that are unneeded. In the previous case, when they suddenly start playing this high-definition video, at that time we commit new resources to meeting the requirement. And this, of course, introduces a lot more efficiency into the operational network, but it requires a more sophisticated capabilities to manage quality of service. So an example of this we have on the private cloud side, a video source. We have created a virtual network, and now we're streaming content across to a device. And again, the load changes, and because the load changes, they start streaming a video, whereas before they were doing something else, but now they're streaming a video. The video needs a lot more bandwidth. The SDN controller becomes aware of this through real-time analytics and issues commands to multiple nodes to adjust resources so that the user experience is what they expect. And of course, we can monitor this all along, and we can actually see, using the SEV1 tools that are monitoring at various places along, we can see the impact of exactly what's going on and confirm that we did achieve a better user experience. Of course, we can see that on the mobile device. The second use case builds on the first use case, but in this case, we have everything running fine, we think everything's good, and all of a sudden we experience a denial of service attack. And this denial of service attack puts extra load on the network, and this load is not really wanted. So in this case, we're going to deploy a virtual network function into a service chain to disrupt the negative effect, the extra load caused by a denial of service attack. So here's a graphic to visualize what we're talking. We have this video streaming across the network, as we see here. You can see the packets depicted by the blue dots, and everything is fine, the user experience is great. But then suddenly, what we call an evil VM, a virtual machine, shows up, and it's just pushing all sorts of packets out in high volume across the network. And the net result of this is it degrades for the end user experience. And we need to mitigate this. So we sense this with real-time analytics. As a result, the SDN controller deploys a firewall in a matter of milliseconds, and once that is deployed, then all of the bad packets go into the firewall and never come out, and the user experience is restored. And when the evil VM goes away, we also retire the firewall. We don't need it anymore, perhaps, and we can turn it down. And if we need one firewall or 100 firewalls or 100 VMs to drive that, we could adjust that up and down as required. All of that driven by real-time analytics. So coming out of this, we observed a number of things. We got great value out of this catalyst because we are in the middle of deploying this type of technology. We use this technology internally. Now we're productizing it and bringing it in a format that can be installed in a private data center on site. And we've noticed that the automation requires a lot of scripting and that describes service orchestration that spans across multiple service controllers. There's additional work that needs to be done at an industry standards level to facilitate that, particularly when you have a number of different vendors involved in the network. And future investigation, which we think we'll pursue in the next iteration, could include that common API that can account for different policy formats based on different types of vendor equipment, the accounting for different protocols that are intended to be in use, and allowing for versioning of those protocols. We also noticed several gaps in the existing the MANO documentation, and we tried to map the architecture to this MANO drawing at a very simplistic level here. But one of the things we notice is that there's a physical orchestration layer that's kind of missing. And when we do the real-time analytics that's necessary to do orchestration across multiple network controllers, this is not really depicted or described in the ETSI documentation. Maybe it's embedded in that OSS block, but there's not a lot of detail on that. So when you physically try to do this, you see that there are some gaps here. The physical orchestration is interesting because there's a lot of work that has to be done at the VXLAN tunnel layer. Maybe an example would be I have in the cloud infrastructure in my resource pool, in my fabric, I might have a 10 gigabit network interface card, and for this particular load, I need a 100 gig network interface card. And that's really physical orchestration that needs to occur before you can even deploy the VXLAN, right? So you have to know what you're talking to, and you may have to make some adjustments at that layer. We see this all the time in our large cloud deployments, and we don't see this addressed yet in this documentation. So next steps is to sync with the Zoom project with our findings and integrate that and coordinate that going forward. And we have some steps outlined potentially for a catalyst that would continue into the NICE event in I guess June 2015. More work on the specifications for common interfaces so that we can for those self-provisioned portals. Investigate management packages, use of similar policy interfaces. We need to validate more the proof of concept across more clouds. There are other vendors and there's other pieces of equipment that could be involved in typical real-world scenarios. The monitoring interfaces could be improved, and there's a lot of work that can be done around investigating optimization and performance. And one of the things we know is that hardware offload is important, particularly at the NIC and the VXLAN, or there's some other capabilities of that layer. And we see that as an extremely important aspect going forward that has to be included in the architecture as the whole concept of SDN network function virtualization evolves. So with that, that concludes our presentation.
Okay. Hey, Eric, one of the things that you stressed in this was the entire multi-cloud type aspects.
Yep.
What kinds of unique challenges do you get when you have this inter-cloud operations versus just an intra-cloud virtualization? So,
Well, one way to think of that is we have, it's a great question because, I used to think of 20 years ago or 30 years ago, we used to think of the intranet, the internet, and the extranet. So you have to, one is the fabric underneath of one data center, which is a complex animal in a very large hyper-scale deployment. And then you have the data centers, the network that extends between the data centers. And then you have to cross a boundary at a co-location point and go into a service provider network and all the way out to the assets. So one problem is, how do you determine where the problem is? If the end user experience is poor, how do you determine, just through kind of what we used to call root cause analysis, where is the problem? So you have to monitor everything. And because you're using virtualized resources, you have to monitor everything in real time. Because you don't know in advance of the deployment what resources are applied. So you have to monitor things, you have to catch an anomaly. And then you have to bubble that up to an orchestration level. In this case, we were using System Center Ops Manager to recognize that there's an issue, and then you can issue commands to the network, potentially more than one network service controller to adjust resource settings to address the problem. Or you can provision certain things at the network, certain policies at the network controller layer, and the analytics can bubble up just to that layer and they can respond automatically. So there's kind of two different approaches, but you have to understand which one you're using for each type of network technology that might be involved in that service chain. So there's a lot of issues, and that's compounded by the fact that you have different equipment. You might have one vendor equipment in the internet and another piece of equipment in the extranet, and you have to understand how to cross those boundaries as well.
Interesting. Now, one other thing that you mentioned in your talk was the not just the ability to scale up, but the ability to scale down.
Absolutely.
Could you talk a little bit more about that?
Absolutely. We are commonly over-engineer networks to deal with the worst-case scenario, the peak half hour, right? And one of the key value propositions here is that we don't have to do that. We can throw resources at a problem in milliseconds in order to adjust the requirements, and then when those resources are no longer needed for that purpose, we can take them out of service. So the ability to scale up and scale down very quickly is essential to getting the economic value out of network function virtualization.
I had one question from the audience that we were just talking about in the denial of service
Yes.
exercise. Did you look at using the TM Forum assets that have been developed around denial of service, or was this done a different way?
We looked at it, but not as well as we could have. The issue for us is that but I don't think we're very far out of alignment.
Okay.
The virtual firewall component exists. It's in production inside Microsoft's Azure network today, so this is not something completely new. This is something that exists. What is new is we're productizing it and making it available as part of the Microsoft Network Cloud Platform, or BNext, which will come out in next summer in terms of general availability. So we are deploying it. I think one of the learnings, though, here is how to capture some of the TM Forum thinking on that. So that was certainly a benefit for this catalyst. So we have a work in progress to productize this, and we will leverage the TM Forum standards wherever possible.
Thank you very much, and congratulations on a successful show.
All right, thank you.